Failure is good. It bruises our egos, makes us question our life decisions, and most importantly, brings us to tears. Wait, wrong script. What I mean is, failing is learning. You can guarantee that of all the lessons I've had in this shop, the most understood, unshakable, and ingrained in my soul are those that came from failure. And not to sound too cliche, but what's important is that you don't give up. Of course, don't just do the same exact thing again and again. That's called insanity. Do something different until you do succeed, even if it takes a year. Because it's true what they say. Redemption is a dish best served cold. This is a sort of part 2 from the last project where I made this badass die holder from a kit sent to me by a fella named Eric. And in that video I teased at a second kit in this box. Well, guess what I'm making now? Surprise, it's a rotary broach. For the uninitiated, it's basically a way of cutting polygonal holes in parts. For example, the hex hole in this screw. The idea is that the cutter is held at an angle and allowed to rotate, so as it's pressed into the work, it grabs on and spins with the material. And because of the angle, only one corner is working at a time. This makes it a whole lot easier to press the tool into the part as opposed to coming straight in like a traditional broach. This works in harder, non-kiddo friendly materials as well, in theory anyway. I say that because I attempted this once before and the results were, well, it didn't work. But this could have been for several reasons. For one, I didn't have the best way of centering the broach on the part I was working on. And the setup I was using on my tool post wasn't very rigid. And I may have been trying to take too large of a cut at once, and I may not have hardened the cutter. So yeah, it didn't work. But this kit solves a lot of those problems, as I'll get to during the build. Plus, this can be used in both the lathe and the mill, which might actually be useful. Of course I already got something on these drawings, because I'm an ape, but other than that, things on here seem pretty reasonable. Or so I thought. I just noticed this is a 2-to-1 scale. This thing is going to be tiny. I guess that would make sense given how small the stock is, but still a little shocking. Now I could try to scale everything up and make this a little more reasonable, but I kind of like the challenge of making something so comically small and intricate. So we're going to roll with it. I guess this will solve my problem of trying to broach too large of a geometry. The drawings were also quite cryptic in areas, so I decided to read the instructions this time. This tool is slightly more scientific, so I wanted to make sure to get it right. And I'm glad I did, because there's actually some pretty important steps in here that the drawings don't exactly convey. For instance, that I should start the build with the locking ring. So let's dive in. This ring is going to need some very fine 0.5mm pitch thread, so I just want to make sure that my lathe is set up for this. And I'm glad I did, because I actually need to swap to the B set of change gears. Normally this isn't a problem, but the collet chuck uses this drawbar, and this drawbar prevents access to those change gears. So better to swap this all out now rather than mid-part. Forgot to put this back in. Gotta love it when you get something all the way back together and find an extra screw. At least I know where it goes. Okay, we should be good to go now. Just one more thing. Yep, hold on to your pants. I figured since everything on this build is metric, might as well commit and change my readouts to metric as well. Let's start by preparing the end for threads. Well, I just realized my first hurdle. None of my measurement tools are metric. I'll just have to keep this calculator handy for the conversions to metric values on the DRO, which I have to do for every measurement. Oh goody. Let's cut the threads. Because this is an imperial lathe with an imperial lead screw, I have to keep the thread feet engaged at all times. This means running forward and reverse between passes. Normally I have to keep a pretty long ramp time on the VFD because it takes a while to speed up and slow down my big chucks. But for this I can shorten this time a lot, to say 1 second XL and decel. And this will let me stop and reverse in a more reasonable time without doofing something up. Let's see how it's coming. Damn, a little too ambitious on those first cuts. I'm already smaller than I meant to go by 10 thou. I mean a quarter millimeter. Sorry, 254 microns. I could probably keep going and just make the female threaded part to match, but that's kinda lame. So I'll just start again on the other side. That way I don't actually have to tell the boss. Also, I'm about done with this. Converting every measurement I take of my imperial tools to metric is, well, it sucks. Don't worry, I'm still machining to the metric spec. It's just a lot easier to convert the final dimension one time to inches, so my micrometer is actually useful. Actually, the drawing already lists the inch values, so it's pretty much insanity to try to do this in metric anyway. Okay, I've got the thread spot on this time, and went ahead and started the hole for the bore. But to finish this out, even my smallest boring bar isn't going to manage. So especially for this project, I bought a couple of these little fellows. They're solid carbide, so they weren't cheap, but this isn't the first time I've been limited by boring bar size. Hence the top-notch grinding work I've done on almost all my other bars. So I think I'll be able to get a lot of use out of these. I'll finish up with a face recess, and then drop a couple of these bad boys on here, and polish it to perfection. Now I need a couple of spanner holes in this face. So over on the mill, I'll get this set up and located in a V-block. And then drill this hole just a little bit deeper because I forgot to actually hit the record button, but I think you get the idea. Too bad too, because I actually broke a drill. Luckily I had 39 spares. Back on the lathe, I'll cut this off, and that's this part done. Ish. As you'll see, there's a lot of stop and go on this project, so I'll come back to this in a bit. Because now it's time to start on the shank. Normally for something like this, I would bring in a live center right from the start to support the work, but as you can see there's a lot of material I'm removing here. And just based on past experience, this usually causes the material to warp as internal stresses are relieved. So what I'll do to mitigate this is still use the live center, but I'll wait until I've got the shank turned down to within 1,000 microns of the final size. I don't know if this actually made a difference, but I'll tell myself it did. Over on the mill, I'll use another V-block setup to start work on the itty-bitty groove on the face of this. And to measure the width, I'll use a stack of gauge blocks, coming in about 2 thou small. But more important than the width is that it's centered. And it just so happens that I'm also 2 thou closer to one side. So a light skim along the one side gets me right on target. Now I'm ready to drill the mounting holes, but of course Dum Dum here completely forgot to leave clearance under the parts. Luckily I now have a good reference here to re-indicate the part after raising it up a bit. Now I just have to make sure not to blast through the bottom too abruptly. What? Now the last job on here, and yes, actually the last job, is to counterbore the other side for the mounting screws. I could manage this with an end mill like I usually do, but I do have a whole stash of actual counterboring bits here that I sometimes check for the right size. These have a pilot boss that keeps the tool centered on the hole. Look at that, I found one exactly the right size. So now I just have to hold this down somehow so I can counterbore this baby. And I think I have just the thing. Sure, I could just clamp this to the table, but it's a whole lot more funner to actually use tools I made. The big advantage of this counterboring bit is that I don't have to spend a bunch of time locating the center of the pilot hole. I can just drop it in place, clamp the part down, and go to work. Is it just me, or do these parts look ridiculously small? Hey Brandon, what do you think?
Very small. Very tiny, very cute. It's a very cute tool. It's going to be very small. Okay?
Okay, sorry I asked. Let's just stick to the machining, starting with the body. We'll start this one off with some facing, turning, and a little drilling, and then we're ready for a whole lot of boring, which is my favorite thing to film because you can see exactly what I'm doing. Anyway, this is basically what I'm going for here, and after boring the smallest diameter, I'll just keep this tool mounted and work through the rest. Or not. I just love the sound of money dropping into the chip tray. I guess I was getting a little too aggressive with my cuts, so no one to blame but myself. I think the name on the box is appropriate this time. Fortunately, I've got this opened up enough that I can use my regular insert boring bar to finish this out. And of course test the fits of the bearings along the way. Now for some super sketch threading to match the locking ring I made earlier. And I say sketch because as if blindly threading inside a bore wasn't stressful enough, my tool is just barely small enough to actually fit, and I can't disengage the thread feed at any point. So yeah, I gotta be on my game here. But thank goodness for DROs and VFDs, and of course an ample helping of OCD. So I'll spare you the 20 odd passes it took me to get to the point where the ring threads in perfectly. Now I can finally tie up one of those loose ends. With the bearing in place, I'll screw in the locking ring and then face this down flush with the body. With one loose end tied up, I've just created another. I have to work on the next piece before finishing this one, so let's work on the spindle. I have to use the leftover stock from the locking ring for this, and I'm glad I didn't chop off this bad end because I would have really screwed myself. Pun intended. The features on this end are conveniently smaller than the old threads on this, so it works out perfectly. This side gets turned down to a snug sliding fit for the large bearing. Before I work on the other end though, I have the bore to address. The instructions recommended saving this for last after everything else is turned down and using a steady rest for support. But my steady rest doesn't get nearly close enough to the chuck for this to work. So instead, I'll do this while my material is still at its largest diameter for the most support. And to do the boring, I'll have to mount my backup cutter, which is even smaller, so hopefully I learned my lesson.
Oh. Yeah. Oh yeah. Nice. Gosh.
That is probably the most perfect fit I've ever bored. After putting a slight 60-degree chamfer on here, I'll bring the live center back in and work on the rest. The smaller diameters on the backside here are recommended to be cut in the same exact setup for maximum concentricity. And to do that, things are about to turn upside down. No, literally. I don't have a right-handed cutter, so I'll do the next best thing and just flip this one over. I just have to reset the height, and always remember to run the lathe in reverse. As in, not that direction. I'm really burning through the tooling on this project, sheesh. Let's try that again. One of the critical measurements here is the thickness of this largest section. It sets the distance between the large bearing and the thrust bearing and needs to be pretty spot on so things aren't rattling around or too tight. So rather than use the values from the drawing, they suggest actually measuring the distance with the bearings in place. I'll take the depth to the thrust bearing, then subtract the distance to the radial bearing, and also subtract its thickness. And that's my target. So back on the lathe, I'll take that down to thickness and work on the remaining diameters. Which of course I can't test fit, so I just have to cross my fingers that my micrometer is reading true. Alright, let's see if I messed anything up. Seems like the locking ring doesn't want to seat all the way. It's actually proud by almost 20 thou. Sorry, I mean half a millimeter. I'm actually at a loss for where I went wrong. Even remeasuring everything, I still get the same exact values. But those obviously aren't correct. I didn't want to do this, but I guess I have to rechuck the part and make some modifications. Luckily, even after remounting, there's almost no run out, so no big deal to come back in here and shorten up everything. Much better. The locking ring sits down flush and there's no play in the bearings. Just one more thing on this spindle. A simple set screw hole in the side for mounting the broaches. And this piece is finished, which means we can finally come back in here and finish out the rest of the body. We'll start with milling a very shallow flat on each side 180 degrees from each other, leaving just a bit untouched at the end. And this clearance hole will give access to the set screw we just added to the spindle. Now clamping on those flats, I can mount the body bottoms up and at a slight angle. But the exact angle is kind of important, so I'll use this 1 degree angle block. After coating the top face in layout blue, I'll bring in the fly cutter and shave down the face a little bit at a time. Since my part is already at length, basically once that last sliver of blue disappears, I know I've gone the right distance. But that finish looks like doo-doo, so let's swap to a fresh insert and take one more light skim pass. Or two. There we go. I'll use the coax like before to find the center line, but because this is at an angle, I have to get the stylus as close to the top edge as possible. And then I can cut away the sides, making a little tab in the middle. Just like on the shank, this tab needs to be right on center line, but the width also needs to be dead nuts. So after a lot of very light adjustments, I get something that pleases my anal retentiveness. The shank slides smooth as butter in one direction while having absolutely no play in the other, just like it needs to be. The last step is just drilling and tapping the 2 mounting holes for the shank screws. Only thing to watch out here for is that I don't drill through to the bearing surfaces inside. I would be devastated to mess something up this far along. Son of a... I'm just kidding. Those holes are supposed to be off-center, and that's actually really important. The broach has to be at an angle to work, but the tip also has to be on center line or it will break. Trust me, I know. So this offset in the back helps get the tip of the broach back on center line. And the slightly oversized holes give a little bit of adjustability to get this spot on when the time comes. But before I can do that, I'm going to need a broach. So guess what we're making next? The kit came with some annealed silver steel for the job. And even though it cuts like butter now, once it's hardened, it should be, well, really hard. The key with these blanks is that they're all exactly the same length. And despite the drawing saying they should be 28mm long, almost all the commercial 8mm shank brooches that I've found are 1.25 inches. So that's why I'm going to make these. Next I need to hex up the ends, which seems like a good excuse to use my fixture plate again, only this time with the tilting attachment. Not only am I cutting a hex shape, but it also needs a 2.5-degree draft angle in the back for clearance. So I'll tram the plate to this angle as well. With a few locating pins, a 1-2-3 block, a collet block, and a clamping strap pulled down tight with the 2 jankiest bolts I could find, I have a properly complicated setup here just how I like. I'll get a rough 0 on the end of the blank, and then partially cut away 2 opposite sides flipping the collet block. Then just measure the result and adjust the final cut depth before running back through all 6 sides. I should probably also mention that I'm making these about 50 microns oversized from the nominal, so I have some Allen key clearance. How about that, I got the unit right on the first try. I joked about my fancy setup here, but this is actually really helpful. All these locating surfaces make it super speedy to bounce from face to face and maintain all of my references. And having made almost all this tooling is a nice cherry on top. I only made 2 brooches for now, and I'm saving the last for a future decision. But I'm sure you're wondering what sizes I went with. Well, let's just say they're 6mm and 4mm. Okay, after a little cleanup chamfering and adding some flats, it's time for the final step. Hardening. With all the painstaking detail the instructions went into for every other operation, I was a little miffed at the lack of guidance at this point. It literally just says I should harden these. Thanks, bro. Ironically, despite actually having a 2nd degree in materials science, this is a bit of foreign territory for me. But after a little refresher, I think I know what to do. Step 1 is to heat to a so-called cherry red color. That looks pretty red to me. For the fastest cooling and the hardest result, I'll dunk and swirl this in water. Now these should be really hard, but they're also probably really brittle. So to toughen them up a bit, I'm going to have to temper them at 100 degrees C for 30 minutes. While we wait for those to bake, I've got just the thing to fill the time. A side project. Having sent me both this brooch kit and the die holder kit for my last video, it occurred to me that maybe Eric just really wants to see some bolts made. So that's exactly what I'll do. Woohoo! They're done! Ow, 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 ow. I'm just kidding. Just a little spiffing up on these and we're about ready to cut. Looking sharp. I've got everything back apart here so we can do a proper greasing. And as if all these little pieces weren't hard enough to handle already, a pair of slimy nitrile gloves made this a real peach. But I got it together and yep, this thing is pretty freaking small. Just about ready to use. It's recommended that the first cuts be in something soft like aluminum. So I'll drill a hole a hair larger than the 6mm hex, then a lead-in chamfer a bit larger than the point-to-point hex dimension. Okay, now we're ready. I've left the back screws loose so the sink can slide and find its center, which it does all by itself by bringing the cutter into the test piece. So I'll stop and tighten the screws, and then continue broaching. That is such a nice fit.
Yeah, baby.
After clearing the chips from the bottom, I'd say that looks pretty damn professional. Okay, let's try this in something harder like those steel bolts I started earlier. No sweat here either. There you go, Eric. I made you some bolts. Well, they're for me, but I made some bolts. But I'm sure you're wondering why such an odd shape. Let's just say next time I need to clamp down my collet block to my fixture plate, I'll be doing so in style. Now this broach is perfectly functional as is, but there's still one final but risky task. And that's to turn down the outside of the whole assembly. Oh, sorry, my camera ran out of memory. What, did you think something catastrophic happened right at the end? Nah, that never happens to me. Despite this tool being way smaller than I originally guessed, I'm still pretty happy with its performance, and it certainly works better than my jerry-rig previous attempt. And what's even cooler is I can use this in the mill as well. That little oscillation you see is why this is sometimes called a wobbler broach. Same exact mechanism as in the lathe, only here the tool is spinning and the material is stationary. I can't really think of a reason why I would actually need to do this, but I'm prepared if I do. Though I might need to refine this second broach a little. Anyway, thank you so much again, Eric, for sending along this batch of kits, and especially this challenging little guy. And hint taken, make all the bolts. Though I'm not sure if that's a curse or a blessing. As always, thanks for watching, and see you next time.